The compasses didn't slowly drift. For several minutes, they became useless. On a quiet day in early September 2016, magnetic observatories across northern Europe and parts of Canada recorded an abrupt disturbance. The Earth's magnetic field did not fade gradually. It dropped unevenly, shifted sideways, and then partially returned. No alarms sounded. No one felt anything. But instruments noticed immediately. Stations in Norway and Finland logged sudden deviations that did not align with solar wind data. Satellites in low Earth orbit registered orientation errors that required unscheduled recalibration. Navigation systems corrected themselves without commands. For a short window, measured in minutes, the magnetic field behaved as if its structure had loosened. Pilots on polar routes later reported conflicting compass readings. Flights continued, guided by inertial systems instead. The incidents were filed and closed. What unsettled researchers was not the strength of the disturbance, it was the pattern. The anomaly did not spread evenly. It appeared in pockets. Regions where magnetic protection thinned more than surrounding areas, then shifted again before stabilizing elsewhere. Like gaps opening and closing, radiation sensors on weather satellites recorded charged particles penetrating deeper into the upper atmosphere during the same interval. Auroral activity intensified far from expected zones. No corresponding solar flare was identified. Internal analyses labeled it a localized magnetic disturbance. But archived data revealed something uncomfortable. Similar signatures appear faintly in records from the early 1970s, and again decades later. Each time brief, each time partially dismissed due to limited instrumentation. This time, the instruments were precise. Atomic clocks synchronized through satellite networks showed small timing inconsistencies during the same window. Not failures, misalignments. The magnetic field is not just a shield. It is a structure systems quietly depend on. For those minutes, that structure did not behave as expected. The event has no public name. It exists in calibration logs, timestamp corrections, and quiet reports. Nothing catastrophic followed, so attention moved on. But the magnetic field continues to weaken overall, and the question remains, unresolved and unanswered. If the planet's magnetic framework can distort suddenly, without warning or cause, how long would it take for anyone to notice if next time it doesn't return to normal?